All right, we're back with part 2 of our basic electrical circuits. In the last part, we made a series circuit with 2 loads, and this time we're gonna build the other type of circuit that we have, which is called a parallel circuit. And I'm just gonna show you again on the wiring diagram before I get started. I'm gonna draw my battery over here. And this time I'm gonna come off the positive of the battery, just like last time, and insert a fuse. That fuse is going to feed a switch, which is going to feed 2 loads just like in the series circuit, but we're going to wire them a little bit differently. And the way we're going to do that is we're going to mount these 2 light bulbs in a way that they're parallel to one another. I'm going to just extend these lines a little bit and back to the ground side of the battery. So the difference between a series and a parallel circuit is fairly easy to see now, where power is going to leave the battery, go through the fuse and the switch, and then when electricity gets here, we're going to have about half of our electricity go this way and half go this way, but the voltage is going to be the same. Voltage is only lost as you're pushing electrons through resistance, like wires, fuses, switches that have very, very low resistance. So if I have my 12.6 volts here, I'm going to push voltage along here with very little resistance, and I'm gonna get to my light bulbs, and let's say I have about 12 volts available there. That means that all I have lost pretty much is 0.6 volts in the wiring and stuff to get here, but both light bulbs are going to receive 12 volts this time as compared to last time. Okay, so we're going to get you a view and build the circuit. So here's my little breadboard here that we built here at our shop just to make very simple circuits on. And that's what we're about to do here, is build a simple circuit. So just like before, I'm going to come off my battery source to a fuse, and I'm going to go ahead and throw a nut on this one now to hold that down. And then from my fuse, I'm going to have a switch, and I have a switch here. It's in the off position, and I'm going to bolt it to my fuse. Okay, so now to wire this parallel circuit, what I'm going to do is I'm going to bolt the switch to one light bulb and the other light bulb. So if we follow the road map here off of our switch, it's going to get to here, and power is going to go to this light bulb and to this light bulb. The only thing it's going to split is its amperage between the 2 light bulbs. The voltage will be identical in both light bulbs, and then they can share the same ground. So I've got my ground connection, and I'll bolt it up here. I'm making all these videos at the same time, so if you've been following me and watching my series circuit video, this is immediately afterwards. So I'm going to take my multimeter, set to volts, and I'm going to test the voltage across my battery before I get started to see what I have available. I have 12.5 volts. So I'm going to hook this up. Just as reference, if you're building yourself circuits or connecting batteries and disconnecting batteries, you always connect your positive first and then your negative last. And then when we disconnect, we're always going to disconnect our negative first, then our positive last. I'm going to go ahead and turn these lights on. And compared to the last video, you should be able to see right away that these lights, and these are the exact same lights, that they're much brighter. These lights are out of a vehicle and they're meant to work on 12 volts. So if I were to take my light now, or my multimeter now, and do voltage drop across the light bulbs, you're going to see that I have available at them 11.96 volts. 11.96. So I had 12.5 available in the battery, and I put 12 across both light bulbs. Power that leaves the battery, think of it as water running through water pipes, let's say. Water is going to run through these pipes, and then they're going to get here, and then the water is going to split, and then it's going to go through both pipes, okay? Because these light bulbs are equally, kind of equal in size and everything, they're going to get about the same amount of water through each one, and then all that water has to return back to the battery. It's not being lost, it's not evaporating or anything, it's returning back to the battery, and that's how I relate amperage to water, flow of water amperage. But voltage is like pressure, and when you get to a light bulb, it's hard to push the water or the electricity through the light bulb per se. So you're going to lose voltage, and the voltage is going to go down to the point where you're going to return back to the battery with 0 volts pretty much. Okay, I hope that was helpful. In a parallel circuit, and I'm going to use 2 layers of paper towel this time because these things are really hot, you can disconnect one bulb and the other one's still going to burn bright. Because the electricity isn't flowing through this one to get to this one, you can have a burnt out tail light and not lose your other side tail light, if you get what I mean here. So parallel circuits is where it's at. That's all that we would use in the automotive industry per se when we're actually putting loads together like this. And if I were to measure the amperage through this circuit, in the series circuit, I said it'd be the same no matter where you measured it. If I measured it here, or at these light bulbs. That's not the case here. If I wanted to measure the total amperage in this circuit, I could take off maybe a connection here and put my amp meter in here, and I could read total amperage. But if I wanted to read individually through each bulb, I would have to break the connection here to measure just one leg of this parallel circuit. If I put these two together, it's going to equal the total amperage in that circuit. I hope that explains things for you clearly. There's the diagram for the parallel circuit, and again, you're just going through a fuse, a switch, and then separately to 2 loads versus that series circuit where the power had to flow through one light bulb to get to the next. Stay tuned for the next video where we're going to be talking about relays.